Are you ready to share?
Are we all going up or just one of us?
It's up to you. It's not a big production, but
Doesn't matter where I put it or you want
that's fine. That works.
So take the x squared and x to the take the return and simplify get x, and then if you plug in like any high number for this, it's just plug out. You get infinity or
Good. So again, we've got the highest powers and M behavior model, and that was the correct way to describe what's up with X. Sometimes people look at X and I don't know, they think that it's something other than X to the first power. X to the first power is always going to reach no intended height. Number 2.
okay, so we took the EDM and that's 2x over x, which simplifies to 2 over x squared. And we know that any number over x is the limit is 0.
That's good. Again, well done. You guys, are you noticing I'm giving you some problems that continue to make you adapt the rules that we came up with? So as was said, any number over x squared. That also is going to reach a limit of 0. Nice job. Group 3. It's yours, so you do what you want with it. Honestly, if you don't do it, I probably will, so love to have you do it. How did the class do with number 3? Do you guys think you got it right? All right, so what do you have for us?
What? Yeah. So if you just do an eating down to 2 and a fraction here, you get 2 is 2 over 1. Minus x over x, highest power, and x over x is 1, just 2 minus 1 is 1. And then, or you can do a common denominator, multiply x plus 1 to fraction of 2 over 1, which will get you 2x plus 2 over x minus 1 minus x over x minus 1, which is equal to x plus 2 over x minus 1, which is equal to x. If you do the EBM of this fraction, you get x plus 2x.
Okay, so just for the sake of people at home, well done. There's two ways to do this, and you can separately do the EBM, or you can pull this together to be one fraction and just do the EBM one time. I would never take off for this, but I just want to mention that technically we're doing the limit. Again, I'm not picking on the person that put this up here, but technically I'm doing the limit of this, and at some point when I do the limit, I end up with my answer. You say, but Ms. Naylor, it's still going to come out to be 1. Yes, but I just want to realize that the limit of 2, the limit of 1, well, that comes out to be 1. Okay, so kind of down here, technically you're doing the limit of this, or the limit of this, and of course, it comes out to be the same answer, because we have constants. This is a good example of having constants that all work out with some simple subtraction. Good, thank you very much. Last group. And again, just kind of how'd the class do? How'd you guys do as a class with this last one?
This one, we cannot use EBM because it does not include infinity, which means that you can't do that. So simply we just use factoring, not the limit.
Good. Honestly, I can't say it better myself, but I'm going to. You don't use the EBM, so you have to use, well, basically you used an analytical method. You realized that you could factor and cancel and end up with that value. Now, none of the groups, and it's fine, none of the groups refer to a graph. I just want you to remember that behind every problem there is a graph, because every limit is an intended height. Okay, whether we're talking about infinity or we're talking about like the last one. So just kind of keep that in mind, because we're going to keep adding stuff to this, but it always goes back to the definition of an intended height. Now, you could start your assignment. I'll be honest that we have a little more to do tomorrow, but if you're just the type of student, you're wondering and you have time, you could start your assignment